The question says that figure 2.13 gives the xt plot of a particle executing one-dimensional simple harmonic motion. You will learn about this motion in detail in chapter number 13. Give the sign of position, velocity, acceleration variables at particle at time t equals to 0.3, 1.2 and minus 1.2 seconds. So we have to give the sign of position, velocity and acceleration at time t equals to 0.3 seconds, 1.2 second and minus 1.2 seconds. So at first let us know a little bit about one-dimensional simple harmonic motion. So simple harmonic motion is a type of motion in which there is a equilibrium point and a body or a particle swings about this equilibrium point. So it will go at first here, then it will come back here with the same distance xx. So this is equilibrium point because at this point of time there is no acceleration acting on the body and it has a maximum velocity, and at this point of at this position, when the body is at this position, let us say position 1 and position 2 and position 3, at this position the velocity is going to be 0 and acceleration is acting in the negative direction. If we take this as the positive direction, then the acceleration, so from point 2 to point 1, when the particle travels from point 2 to point 1, it decreases its velocity. As I said before, at point 2 the velocity is maximum, and as soon as it reaches point 1 its velocity decreases to 0. So when it travels from 2 to 1 its velocity decreases, so acceleration is negative when it is moving away from the equilibrium point. Now when it moves towards when it goes from 2 to 1, acceleration is negative. Now when it moves towards the equilibrium point, then its velocity is increasing or its acceleration is positive. And as soon as it passes the equilibrium point to go in this direction, again the acceleration is going to be opposite, in the opposite direction, that is in this direction. So this time the velocity is in negative direction and the acceleration is in positive direction. So this keeps on happening. Now the same is represented in this graph, as it says that it is executing a one-dimensional simple harmonic motion. So let us see the points of the three main points in this motion. Let us point out it in the graph. The equilibrium point is where the position coordinate is 0. So these are the equilibrium points. At these points the acceleration is going to be 0, as we discussed right now. And at the extreme points the acceleration is in the opposite direction of initial body movement. So when we consider this as the extreme point, then the body was moving in the negative x direction, so its acceleration is going to be positive. So this point may be represented by this third coordinate where x is negative. So while body is here, we can say that when the body is going from equilibrium position to its negative extreme position, then we can say that the acceleration is acting in the positive x direction. So acceleration will be positive in this point. So we have a question where it at time 0.3 seconds, so this would be somewhat 0.5 second and 0.3 second would be here. So this is the extreme negative point, and so the acceleration is going to be in the positive direction. So acceleration is going to be positive. Now velocity, since it is moving in the negative x direction, so its velocity is already going to be negative. And since it is in the negative x direction, so position is also going to be negative. Now let us consider point 1.2. So this point would be 1.5. So 1.2 would be here. Now the body is traveling from its equilibrium position to its extreme positive side. So the body is traveling from 2 to 1. So when the body is traveling from 2 to 1, its acceleration would be in the negative direction, because it is inhibiting, which will lead to zero velocity at this point of time. So we can say that its acceleration is negative direction at second 1.2. Since it is traveling in the positive x direction, so its velocity is going to be positive, and since it is above the graph of time t, so it is going to be positive. Position is also going to be positive. Now consider the third case where it is minus 1.2 seconds. So this is going to be minus 1.5 and minus 1.2 would be here. So we see here that the body from negative x direction, the negative extreme point, it is moving towards zero equilibrium position. In this part of the graph, we see that from point 3 to point 2 movement is there of the particle. So while it is moving to point 2 or the equilibrium position, its velocity is increasing and its acceleration is in positive x direction, because the body has recovered from zero velocity to, and now the acceleration is acting in the positive x direction, which will lead to increase in velocity. So the velocity will be positive. The velocity is going to be in this direction, that is the positive x direction, so it's going to be positive. Acceleration is also going to be positive. Now position is negative because it is in the negative x direction. Thank you.